Look at the shadows slowly shifting across the floor of the room you are in. As the sun makes its long, silent journey across the sky, dragging alternating curtains of light and dark in its quiet wake, we are witnessing the oldest and most fundamental clock in the entire universe. Time is a silent, invisible river, carrying us forward from the very moment we are born to the moment we finally fade, an untouchable and unrelenting force. We cannot see time in its pure form. We cannot hold it in our hands, we cannot pause it, and we cannot slow it down, no matter how desperately we might wish to linger in a perfect moment. And yet, humanity has spent its entire history trying to catch it, trying to measure it, trying to map its endless flow. We have built massive monuments of rough-hewn stone, carved meticulous notches into the bones of animals, designed incredibly intricate cages of brass and gear, and ultimately learned to capture the tiny, invisible vibrations of single atoms, all in a relentless, obsessive quest to measure the invisible current that carries us all. This monumental pursuit has shaped our ancient cities, aligned our crucial harvests, guided our fragile wooden ships across trackless and terrifying oceans, and built the very foundation of the modern, hyper-connected world we inhabit today. This is Quiet Codex, a calm corner of YouTube dedicated to helping you wind down with fascinating facts and calming theories. If you are seeking a moment of peace, a gentle distraction from the overwhelming noise and rush of the day, you have found the right place. Please take a deep breath. Let your shoulders drop and allow the tension to simply melt away into the quiet. If you enjoy these calm explorations and find yourself drifting off to them, a like and a subscribe would truly help the channel continue to grow. Your support means the absolute world to us, and we are so very grateful that you are here tonight, sharing this quiet space with us. We live our entire lives dictated by the numbers on a clock and the rigid boxes on a calendar, rarely pausing to consider how profoundly bizarre it is that we have trapped the concept of infinity inside a circular dial on our wrists or a grid of numbered squares hanging on a kitchen wall. We trust our calendars implicitly, without a second thought. We schedule our days, our years, our entire existences around an invisible grid of hours and months. But this grid is not a natural law of the universe. It is an invention, a grand, beautiful, and fundamentally flawed human construction pieced together over tens of thousands of years through a delicate mixture of patient observation, deep religious devotion, fierce political maneuvering, and elegant mathematics. The evolution of timekeeping is a story of our evolving understanding of the cosmos itself. It is a story that begins in the profound dark, under the vast, unpolluted canopy of a prehistoric sky, where the only hands on the clock were the shifting, glowing phases of the moon and the slow, majestic wheeling of the distant stars. Tonight, we will trace that incredible journey from the very beginning. We will travel together from the earliest shadows cast upon the dirt by ancient wanderers to the hyper-precise optical lattice clocks of the distant future. So relax your mind, settle deeply into wherever you are resting, and let us wander through the quiet, sweeping history of how humanity learned to measure the infinite nature of time. Let us travel back tens of thousands of years, long before the invention of the written word, long before the very first cities rose from the mud and clay, to a vast era when human survival depended entirely on reading the subtle signs of the natural world. Imagine standing on a cold, wind-swept plain 20,000 years ago. The world around you is dark, wild, and deeply mysterious. But above you, stretching from horizon to horizon, the night sky is a flawless, brilliantly glowing map of light. The ancient wanderers who walked beneath those stars were not primitive in their minds. They possessed the exact same intelligence we do today, the same complex pattern-seeking brains, the same capacity for wonder, and they looked up. They noticed that the moon was not a static object. They watched it swell over many nights from a thin, razor-sharp silver sliver into a brilliant, dominating orb that bathed the landscape in pale light, and then shrink back into the total darkness of the new moon, over a highly predictable, repeating cycle. This beautiful celestial cycle became the very first measure of passing time that extended longer than a single day and night. Deep within the lush, ancient environments of the Democratic Republic of Congo, modern archaeologists discovered a small, unassuming artifact that changed our understanding of ancient mines. It is known as the Ishango Bone. This artifact is a piece of a baboon fibula dating back approximately 20,000 years, carefully and deliberately carved with 3 distinct columns of asymmetrical notches. While its exact original purpose remains heavily debated among scholars and historians, many prominent researchers interpret these careful, deliberate groupings as a prehistoric lunar calendar, a physical, tangible record of an ancient human mind tracking the phases of the moon across the sky. This small, fragile bone represents a profound leap in human cognition. It marks the precise moment in our deep history when we stopped merely experiencing the passage of time and began to actively record it, to quantify it, and to pull it down from the heavens into our hands. Long before the concept of written language was ever conceived, ancient peoples across the globe were building monumental, earth-shaking structures to track the celestial cycles. In the rolling green fields of Aberdeenshire in Scotland, archaeologists recently unearthed a series of 12 massive pits known as the Warren Field Calendar. Created around 10,000 years ago by hunter-gatherer societies, these ancient pits align meticulously with the midwinter sunrise and were used to track the lunar months, keeping these nomadic tribes perfectly synchronized with the turning of the harsh seasons. This specific site is currently considered the earliest known calendar system anywhere on Earth. The deep urge to track time was a universal human trait. On the windswept Salisbury Plain in England, the massive, imposing standing stones of Stonehenge were dragged from miles away and erected over centuries, beginning around 3,000 years before the Common Era. These silent, towering megaliths were not merely religious monuments built for forgotten gods. They were sophisticated, massive astronomical observatories. The great heelstone of the monument perfectly frames the sunrise on the exact morning of the summer solstice, while other careful alignments mark the absolute shortest day of the cold winter. The ancient people who built Stonehenge left no written records, no books, no scrolls, but they left their deep understanding of time etched permanently in monumental stone. They knew, with absolute certainty, that the sun and the moon dictated the entire life cycle of the earth, the massive migration of animal herds, and the ripening of wild foods. To understand the sky was to understand how to survive. Timekeeping, in those ancient days, was not a matter of convenience or scheduling. It was a matter of absolute life and death. As human societies gradually grew larger and significantly more complex, slowly settling down to plant crops, domesticate animals, and build the first sprawling cities, the informal, casual observation of the moon and sun was no longer sufficient. The monumental transition from nomadic hunting and gathering to sedentary agriculture required precise, long-term planning. Seeds had to be planted at exactly the right time to avoid the devastating late frosts, and heavy harvests had to be gathered before the destructive winter rains arrived. The Bronze Age saw the spectacular birth of the very first formal, institutionalized calendar systems, emerging from the rich, fertile crescent between the Tigris and Euphrates rivers. The ancient Sumerians and Babylonians of Mesopotamia were meticulous, obsessive record keepers. With their brilliant invention of cuneiform writing, using wedge-shaped styluses on wet clay, they began to document the complex movements of the heavens on thousands of heavy clay tablets. The Babylonian astronomers developed a formal, highly structured lunar calendar based specifically on the synodic month, which is the period it takes for the moon to complete its entire cycle of phases, returning to exactly the same visual state. They calculated this to be roughly 29.5 days. To create a working year, they established a system of 12 lunar months, alternating between 29 and 30 days, yielding a civil year of approximately 354 days. But right here, at the dawn of civilization, humanity encountered the greatest mathematical challenge of timekeeping, a fundamental, unyielding mismatch in the physical machinery of the solar system. The phases of the moon do not fit evenly or neatly into the cycle of the Earth orbiting the sun. A 12-month lunar year is roughly 11 days shorter than the actual solar year. If a civilization relies strictly and only on a lunar calendar, the months will quickly and chaotically drift out of alignment with the physical seasons. Within a single decade, a spring planting festival would suddenly fall in the freezing middle of winter. To solve this monumental problem, the brilliant Babylonian astronomers introduced the concept of intercalation. They created a complex lunisolar system, periodically inserting an extra 13th leap month into the calendar to forcefully yank the lunar schedule back into alignment with the agricultural seasons. This practice required constant, vigilant astronomical observation and highly complex mathematics. The Babylonians also gave us a mathematical legacy that we still use every single day of our lives. They operated on a base 60 numerical system known as sexagesimal mathematics. It is because of the ancient Babylonians and their reverence for the number 60 that we divide our hours into exactly 60 minutes and our minutes into exactly 60 seconds. Every single time you glance at a clock, you are reading time through the mathematical eyes of a magnificent civilization that vanished beneath the desert sands thousands of years ago. While the Babylonians looked primarily to the moon, the ancient Egyptians looked to the blazing sun and the distant stars, driven entirely by the unique, life-giving geography of their homeland. Egypt was a civilization completely dependent on the rhythmic pulse of the Nile River. Every single year, without fail, the Nile flooded its banks, depositing rich, dark, life-giving silt along the valley, transforming the arid, brutal desert into a lush, fertile paradise capable of sustaining millions of people. Predicting the exact arrival of this flood was the absolute most important task of the powerful Egyptian priesthood. They quickly realized that a lunar calendar, which was constantly drifting out of phase with the solar year, was completely useless for predicting an annual geological event driven by the sun. However, the patient Egyptian astronomers noticed a recurring celestial pattern. Just before the annual flooding began, a brilliant, piercing star they called Sothis, which we know today as Sirius, would appear on the eastern horizon just before sunrise after a long period of invisibility. This dramatic event, known as a heliacal rising, occurred with remarkable clockwork regularity. By counting the exact number of days between these risings, the Egyptian astronomers calculated the true solar year to be exactly 365 days. Around 3,100 years before the Common Era, they established the first highly practical, formal civil calendar based entirely on the sun. The Egyptian civil year was elegantly, beautifully simple, entirely abandoning the messy, shifting fractions of the lunar cycle. They cleanly divided the year into 3 long seasons of 4 months each, corresponding exactly to the flooding, the planting, and the harvesting of their crops. Each of these months was exactly 30 days long. This totaled 360 days. To complete the solar year, they added 5 extra days, known as epigomenal days, at the very end of the calendar. These 5 days were considered highly magical, existing outside the normal flow of time, and were celebrated massively as the birthdays of their chief gods. This 365-day calendar was a masterpiece of administrative efficiency, allowing the pharaohs to collect taxes reliably, schedule monumental construction projects like the pyramids, and manage agricultural production with unprecedented steady precision. The Egyptians also pioneered the measurement of time within the day itself. Under the blazing, relentless desert sun, they developed sophisticated shadow clocks and towering needle-like obelisks. By observing how the shadows cast by these great stone pillars moved and changed length across the paved courtyards, they divided the daylight hours into 12 equal parts. Because the actual length of a day changes with the passing seasons, these temporal hours were longer in the height of summer and shorter in the depths of winter, a fluid, stretching concept of time that perfectly suited a society governed entirely by the natural, breathing rhythms of daylight and darkness. The quest to organize and dominate time was not isolated to the Mediterranean and the Middle East. Across the world, completely separated by oceans and continents, other civilizations were independently developing incredibly complex calendar systems, each reflecting their unique cosmologies and staggering mathematical achievements. In the dense, steaming rainforests of Central America, the ancient Maya developed one of the most sophisticated, mathematically precise, and philosophically deep timekeeping systems in all of human history. The Mayan calendar was not a single linear track of time like ours, but rather three interlocking cyclical systems working simultaneously like a massive, divine set of cosmic gears. First, there was the Tzolk'in, a deeply sacred calendar of 260 days used exclusively for complex divination, prophecy, and determining the dates of religious rituals. This specific cycle is incredibly ancient, dating back to at least 600 years before the Common Era. And remarkably, it is still in continuous use by traditional Maya daykeepers in the remote highlands of Guatemala today. Running alongside this sacred calendar was the Hab, a 365-day civil calendar consisting of 18 months of exactly 20 days each, plus an ominous, unlucky 5-day period at the end of the year. The true, staggering genius of the Maya lay in perfectly combining these two separate cycles. The Tzolk'in and the Hab interlocked mathematically to create the calendar round, a period of roughly 52 years, where any specific combination of days would not repeat itself. It was the span of a human lifetime. But for recording vast, unimaginable expanses of historical and mythological time, the Maya used a system known as the long count. The long count carefully tallied the individual days elapsed since a mythological, foundational creation date corresponding to August of the year 3114 before the Common Era. Using a sophisticated base 20 numerical system, the Maya calculated vast epochs of time spanning thousands of years. Through their patient observations, they determined the length of the solar year to be 365.2420 days, a measurement so astonishingly, beautifully accurate that it is only a tiny fraction of a day off from our modern, highly advanced telescope-derived measurements. They achieved this staggering precision without metal tools, without wheeled vehicles, and without optical instruments of any kind, relying purely on generations of patient, naked-eye observation and brilliant, rigorous mathematics. Their profound understanding of time was cyclical, a deeply held belief that the universe moves through endlessly repeating eras of creation and destruction. philosophy deeply woven into the stones of their monumental architecture and the intricate curves of their complex hieroglyphic writing. In East Asia, another monumental and deeply enduring timekeeping tradition arose. The traditional Chinese calendar, with ancient origins believed to trace back to around 2,500 years before the Common Era, is a highly sophisticated lunisolar system. Unlike the purely solar Egyptian calendar, the traditional Chinese system carefully, respectfully balances the competing cycles of both the blazing sun and the pale moon. A standard year contains 12 lunar months, but to prevent the seasons from drifting into chaos, an entire leap month is added approximately every 3 years. This precise mathematical calibration ensures that the crucial winter solstice always falls exactly in the 11th month. The Chinese calendar is perhaps most famous globally for its 60-year grand cycle, which elegantly combines a 12-year animal zodiac with 10 heavenly stems, representing the 5 fundamental elements of nature. This calendar does not merely count empty days. It measures the quality and energy of time itself, guiding everything from agricultural planning and political decisions to personal astrological predictions, and it continues to determine the exact dates of major, vibrant cultural observances like the Lunar New Year and the Mid-Autumn Festival today. Similar lunisolar complexities govern the ancient Hebrew calendar, which uses a mathematically beautiful 19-year cycle to align its strictly lunar months with the broader solar year, ensuring that the critical festival of Passover always falls correctly in the spring. In sharp contrast, the Islamic Hijri calendar is a purely, uncompromisingly lunar system. Established in the year 622 of the Common Era, it strictly observes 12 lunar months totaling roughly 354 days, entirely without any intercalary corrections or leap months. Because it intentionally ignores the solar cycle completely, Islamic holidays cycle slowly through all the seasons over a 33-year period, prioritizing the visual purity of the lunar phase and religious devotion over agricultural alignment. Returning our gaze to the Western world, the story of our modern calendar finds its chaotic roots in the turbulent politics of the early Roman Empire. The early Roman calendar was, to put it mildly, a disorganized, confusing mess. Legend says it originally contained only 10 months, beginning in March and ending in December, leaving the cold, dead period of winter entirely uncounted and unnamed. Later, kings eventually added January and February, creating a 355-day lunar year. To keep this deeply flawed calendar aligned with the shifting seasons, the highest priests of Rome, the pontiffs, were supposed to occasionally and responsibly insert a leap month. However, the pontiffs were also highly corrupt politicians. They would routinely manipulate the calendar for their own personal gain, arbitrarily extending the years when their political allies were in power and artificially shortening them when their bitter enemies took office. By the time Julius Caesar rose to absolute, unassailable power in the 1st century before the Common Era, the calendar was utterly broken. The civic dates had drifted a full 3 months away from the actual solar seasons. The traditional autumn harvest festivals were bizarrely falling in the middle of the scorching summer. Julius Caesar, advised by the brilliant and pragmatic Alexandrian astronomer Sosigenes, decided to abolish the old, corrupt system entirely. In 46 before the Common Era, he enacted the sweeping Julian reform, establishing a purely solar calendar modeled directly and unapologetically on the ancient Egyptian system. Caesar decreed that the new year would consist of exactly 365 days, divided neatly into 12 months of 30 and 31 days, with the final month of February receiving 28. To solve the persistent problem of the fractional solar day, he introduced a brilliant and enduringly simple rule, adding 1 extra leap day to February every 4 years. To correct the massive 3-month accumulated drift of the old calendar, Caesar brutally ordered that the year 46 before the Common Era would be stretched to an incredible, agonizing 445 days, a chaotic period known to weary historians as the Year of Confusion. The new Julian calendar finally took effect the following year, bringing unprecedented, desperately needed stability to the vast, sprawling Roman Empire. It was a monumental, civilization-altering achievement, a calendar so robust, so perfectly suited to administration that it would serve Europe as the unquestioned standard of time for more than 1,600 years. The very names of the months we use today, including July named for Caesar himself and August for his successor, are direct, echoing legacies of this ancient Roman decree. But the mighty Julian calendar harbored a tiny, insidious, almost imperceptible mathematical flaw. Caesar's elegant system assumed the solar year was exactly 365.25 days long. In mathematical reality, the tropical year is approximately 365.2422 days. This means the Julian calendar overestimated the length of the year by roughly 11 minutes and 14 seconds. 11 minutes seems entirely negligible, a tiny rounding error in the grand scheme of a single human lifetime. But calendars are built to endure for centuries. Over the span of 128 years, those spare 11 minutes quietly accumulated into a full day of error. The calendar was slowly, inexorably, silently falling behind the actual physical position of the Earth in its orbit around the Sun. By the 16th century, this creeping mathematical drift had accumulated to a massive, undeniable 10 days. The spring equinox, the crucial astronomical event upon which the date of Easter is calculated, was occurring around March 11th instead of March 21st. For the deeply powerful Catholic Church, this was a profound theological crisis. They were celebrating the holiest, most important day of the Christian year on the wrong astronomical date, throwing their spiritual alignment with the cosmos into jeopardy. In 1582, Pope Gregory XIII took decisive action, issuing a powerful papal bull known as Inter Gravissimus, enacting the Gregorian calendar reform. Advised extensively by the brilliant Jesuit mathematician Christopher Clavius, the Pope ordered two drastic, world-altering changes. First, to wipe out the accumulated error of the centuries, 10 days were simply deleted from existence by decree. Thursday, October 4th, 1582, was immediately followed by Friday, October 15th. People went to sleep on the 4th and woke up on the 15th, their rents, wages, and interest calculations thrown into temporary, bitter chaos. Second, the reform subtly modified the leap year rule to prevent the drift from ever happening again. Century years, like 1700 or 1800, would no longer be leap years unless they were also completely divisible by 400. This highly elegant mathematical tweak shortened the average calendar year to 365.2425 days, achieving an astonishing accuracy that drifts by only one single day every 3,000 years. Because it was fundamentally a Catholic papal decree, Protestant and Orthodox countries stubbornly, angrily resisted the change for centuries, creating a bizarre era where crossing a European border meant literally traveling 10 days into the future or the past. Great Britain and its distant American colonies did not finally adopt the Gregorian calendar until 1752, famously resulting in George Washington's actual birthday shifting by 11 days. Ultimately, the sheer mathematical superiority of the Gregorian system won out, becoming the globally accepted, undisputed standard for civil timekeeping that we use to structure our lives today. While the grand calendar organized the sweeping, majestic progression of seasons and years, humanity also desperately needed a way to track the fleeting, immediate hours of the day. For thousands of years, the simple sundial was the undisputed king of civil time. It was elegant, profoundly reliable, and fundamentally tied to the visible cosmos. But the sundial had a fatal, inescapable flaw. It was completely, utterly useless at night or under the heavy, obscuring cover of rain clouds. To escape the rigid tyranny of the sun, ancient engineers turned their brilliant minds to the earthly elements of water and fire. The water clock, known as the clepsydra, which literally translates to water thief, became the primary instrument for indoor and nocturnal timekeeping across the ancient world. By carefully measuring the regulated, steady flow of water into or out of a marked vessel, the Egyptians, Greeks, and Romans could track the passing hours in complete darkness. Water clocks slowly evolved from simple stone bowls with holes drilled in the bottom to incredibly complex gear-driven machines. In the late 11th century, the brilliant Chinese polymath Su Song constructed a monumental water-powered astronomical clock tower. Standing over 30 feet tall, it featured an intricate armillary sphere, a rotating celestial globe, and mechanized wooden figures that faithfully struck gongs and bells to announce the time, representing the absolute pinnacle of medieval mechanical engineering. In other parts of the world, time was measured by the slow, steady, and mesmerizing consumption of fire. In imperial China, intricate incense clocks burned specially formulated powders along a measured, winding path, marking the passing hours not just visually but aromatically, releasing completely different, distinct scents into the air as the long day progressed. In medieval Europe, simple candle clocks marked with precise, painted intervals were used by devoted monks to perfectly time their midnight prayers in freezing stone monasteries. And the iconic hourglass, relying entirely on the quiet, continuous flow of fine sand through a remarkably narrow glass neck, became essential on the high seas, unaffected by the violent rocking of a ship or the dampness of the ocean air. But all of these devices, whether they relied on water, fire, or sand, shared the exact same fundamental limitation. They relied on continuous processes that were highly sensitive to their surrounding environment. Water could freeze solid or evaporate, its crucial viscosity changing constantly with the shifting temperature. Candles drafted wildly in the breeze, and fine sand could easily clump in high humidity. They were clever, beautiful approximations, but they lacked the rigid, unyielding mathematical precision that a rapidly advancing society increasingly required. The true revolution in timekeeping, the staggering technological leap that would ultimately build the modern, synchronized world, occurred in the late 13th century with the brilliant invention of the escapement mechanism. This unassuming mechanical device fundamentally, irrevocably changed how humanity measured time. Instead of relying on the smooth, continuous flow of a substance, the escapement brilliantly converted the continuous, powerful pull of a falling weight into discrete, carefully measured oscillations. It violently divided time into separate, identical ticks. The earliest known mechanism, known as the verge and foliot, featured a heavy horizontal bar that swung back and forth, pushed and caught by a rigidly geared wheel. These early mechanical clocks were massive, lumbering iron beasts forged by heavy blacksmiths and installed high in the towers of European cathedrals. They were wildly inaccurate, often losing or gaining up to half an hour every single day, and they possessed no faces or delicate hands. They simply struck a massive, heavy bell to loudly call the town to prayer or to the bustling market. But despite their crude nature, they represented a profound philosophical shift in human history. Time was no longer a fluid, gentle river. It was a machine, a rigid sequence of quantified, mechanical, unending beats. For hundreds of years, dedicated clockmakers struggled endlessly to improve the terrible accuracy of the verge and foliot. The crucial breakthrough finally came from the brilliant mind of the great Dutch mathematician and physicist Christiaan Huygens in 1656. Building heavily on the earlier observations of Galileo, Huygens designed the very first successful pendulum clock. A swinging pendulum possesses a remarkable, almost magical physical property called isochronism. Whether it swings in a wide sweeping arc or a narrow, gentle one, it takes the exact same amount of time to complete one full oscillation, provided the length of the pendulum remains perfectly constant. By using a swinging pendulum to carefully regulate the escapement, Huygens miraculously reduced the error of clocks from 15 minutes a day to a staggering 15 seconds a day. The pendulum clock brought absolute, unyielding mathematical regularity to timekeeping for the very first time. It allowed for the addition of the minute hand, and eventually the rapidly sweeping second hand, transforming the clock from a rough, unreliable estimate of the hour into an instrument of high-precision science. As clocks became more incredibly accurate, they enabled the aggressive global expansion of European empires, solving one of the deadliest, most terrifying mathematical puzzles of the age, the longitude problem. While navigators could easily determine their latitude north or south by simply measuring the angle of the sun or the North Star, determining their longitude east or west required knowing the exact time at a known reference point, like London, and comparing it to the local solar time on the ship. The Earth rotates exactly 360 degrees every 24 hours, meaning every 15 degrees of longitude equals a time difference of exactly 1 hour. If a desperate captain knew it was exactly noon locally, and their clock told them it was 2 in the afternoon in London, they knew they were exactly 30 degrees west of the prime meridian. But delicate pendulum clocks were utterly useless on the violent, heaving deck of a ship at sea. Without absolutely accurate time, massive fleets of ships frequently crashed blindly into unseen rocks, resulting in catastrophic, horrific losses of life and treasure. In 1714, the British government offered a massive fortune, the longitude prize, to anyone who could solve the impossible problem. While the greatest, most educated astronomers of the era tried to map the impossibly complex movements of the moon to create a celestial clock, a self-educated English carpenter and clockmaker named John Harrison took a radically different path. He spent his entire, obsessive life designing a mechanical clock that could withstand the absolute brutality of the ocean. After decades of relentless, punishing innovation, creating frictionless gears and brilliant bimetallic strips that expanded and contracted to perfectly cancel out wild temperature changes, Harrison produced his masterpiece, the H4 marine chronometer. It looked like a very large, incredibly complex silver pocket watch. In 1762, the H4 was tested on a brutal, storm-tossed voyage to Jamaica. When the ship finally arrived after months at sea, the clock had lost only a few incredible seconds. Harrison had literally captured time in a brass cage, allowing ships to navigate the featureless, terrifying oceans with absolute certainty, fundamentally altering the entire course of global trade and exploration forever. Back on solid land, time remained a fiercely, stubbornly local phenomenon well into the 19th century. Before the massive industrial era, every single town on Earth kept its own local solar time. When the blazing sun reached its absolute highest point in the sky, the town clock was simply set to noon. Because the Earth is curved, local noon happens at a slightly different moment for every city. Washington was minutes ahead of Chicago, which was minutes ahead of Denver. In a world where the absolute fastest mode of transportation was a galloping horse, These minute local differences did not matter at all. But the terrifying invention of the steam locomotive shattered this peaceful, localized isolation completely. As powerful railroads spread massive, interconnecting webs of iron across vast continents, heavy trains began traveling much faster than the local time changed. A weary conductor traveling across the country encountered dozens of competing, entirely correct local times. Scheduling trains became a terrifying, deadly nightmare. Horrific head-on collisions were frequent simply because two stations 50 miles apart were operating on clocks that were entirely unsynchronized. The massive railroad companies quickly realized that organic solar time was no longer compatible with furious industrial speed. In Great Britain, the Great Western Railway unilaterally adopted Greenwich Mean Time for all its timetables in 1840, forcefully requiring towns along the line to conform to a single dictated standard. The need for a global, coordinated system became undeniable. In October 1884, powerful delegates from 25 nations gathered in Washington for the International Meridian Conference. They voted overwhelmingly to establish a single prime meridian, a line of absolute zero longitude from which all global time would be rigidly calculated. They selected the transit circle at the Royal Observatory in Greenwich, London, largely because the massive British shipping fleet already used Greenwich on its nautical charts. The Earth was conceptually, invisibly sliced into 24 strict time zones, each representing 1 hour of the Earth's rotation. The chaotic, organic reality of local solar time was entirely paved over by a rigid, standardized administrative grid. The clock no longer reflected the sun above your town. It reflected your designated geographical zone, dictated entirely by international treaty. In the 20th century, the relentless human quest for precision left the mechanical realm entirely, diving deep into the subatomic architecture of the universe itself. Even the most perfectly crafted mechanical clocks rely on physical springs and metal gears, subject to inescapable wear, friction, and gravity. In the 1920s, scientists discovered that passing an electric current through a small quartz crystal causes it to vibrate at a highly stable, incredibly specific frequency. Quartz clocks utterly revolutionized timekeeping, losing only seconds a month and making highly accurate watches cheaply available to the entire global population. But for the most incredibly advanced scientific applications, from deep space navigation to the complex synchronization of global telecommunication networks, even quartz was not nearly stable enough. The ultimate, perfect timekeeper could not be manufactured in a factory. It had to be found hidden within the fundamental laws of physics themselves. In 1955, brilliant scientists in the United Kingdom built the first highly accurate atomic clock, using the heavy element cesium. An atomic clock does not tick with a swinging pendulum or a vibrating crystal. It ticks by measuring the natural, unalterable resonance frequency of a single atom. When a cesium-133 atom is carefully exposed to a specific frequency of microwave radiation, its electrons jump between two very specific, rigid energy states. This quantum transition happens with absolute, staggering, unchanging regularity. In 1967, the international scientific community made a profound historic decision. They completely abandoned the astronomical definition of the second, which had always been based loosely on a fraction of the Earth's rotation. Instead, they boldly redefined the second as the duration of 9,192,631,770 periods of the radiation corresponding to the transition between two energy levels of the cesium atom. We officially unmoored our concept of time from the spinning of our physical planet, anchoring it instead to the pure quantum vibrations of the universe. Modern atomic clocks are so incredibly precise that they will not lose or gain a single second in hundreds of millions of years. But this absolute, terrifying quantum perfection created a new, bizarre problem for modern society. Atomic time is perfectly constant, but the rotation of the Earth is absolutely not. The heavy gravitational pull of the Moon, the massive sloshing of the global oceans, and the shifting of the Earth's deep crust all cause our planet to slowly, irregularly decelerate. The Earth is a sloppy, wobbling, imperfect clock compared to a cesium atom. Because of this, coordinated universal time, the global standard based heavily on atomic clocks, gradually drifts away from astronomical solar time. To forcefully keep the atomic clocks aligned with the sun, scientists establish the highly controversial leap second. Occasionally, when the drift approaches 1 full second, an extra second is artificially, jarringly inserted into the global timekeeping system. The clock strikes 23 hours, 59 minutes, and 60 seconds before finally turning to midnight. For the vast majority of human history, a single spare second was meaningless. But in our modern, hyper-connected digital world, a leap second is a terrifying technological earthquake. Global computer networks, financial trading algorithms, and delicate satellite navigation systems demand absolute, continuous, unbroken synchronization. Inserting an unexpected, irregular 61st second into a minute has repeatedly caused massive server crashes, grounded thousands of commercial airline flights, and severely disrupted global internet infrastructure. Because the Earth's rotation is wildly unpredictable, leap seconds cannot be scheduled years in advance, making them a recurring, absolute nightmare for software engineers everywhere. The massive disruption has become so severe that in 2022, the international metrology community voted to suspend the use of the leap second by the year 2035. We have collectively decided that the mathematical perfection of our networks is more important than keeping our clocks perfectly synchronized with the rotation of the Earth. In the future, astronomical time and atomic time will be allowed to slowly drift apart forever, perhaps requiring a leap minute a century from now. The wild frontier of timekeeping continues to aggressively push into strange realms that defy everyday comprehension. highly funded laboratories around the world are developing optical lattice clocks, using lasers to trap incredibly cold atoms of strontium or ytterbium. These magical optical clocks tick at frequencies tens of thousands of times faster than microwaves, achieving a precision so extreme that they would not lose a single second if left running for the entire 15-billion-year lifespan of the universe. They are so incredibly sensitive that they can physically measure Einstein's theory of general relativity on a tiny tabletop. If you lift one of these clocks by just a few centimeters, it will visibly tick slightly faster because it has moved infinitesimally further away from the heavy gravitational pull of the Earth. Time is not a constant, rigid backdrop to the universe. It is a flexible, bending fabric, warping and stretching violently around mass and gravity. We have built clocks so perfect that they no longer just tell the time. They measure the very shape of space-time itself. To truly appreciate the incredible, civilization-altering shift that mechanical time brought to humanity, we must deeply consider the profound psychological impact of the clock on the human mind. Before the relentless, inescapable ticking of the early escapement mechanisms, time was a deeply personal, fluid, and natural experience. You worked when the sun rose, and you rested when the darkness fell. The length of an hour stretched and compressed, depending entirely on the season, moving in slow, breathing harmony with the tilt of the earth. But the mechanical clock severed that ancient organic connection forever. It introduced the modern, stressful concept of being late. Suddenly, a worker was not just working for the day, they were working against the rigid, unyielding mathematical authority of a machine. The factory whistle, powered by the steam of the Industrial Revolution and synchronized entirely by the mechanical clock, dictated human behavior with a level of precision and control that no king or emperor had ever achieved. Humanity had finally trapped time inside a box of gears, but in doing so, time had ultimately trapped humanity. The gentle, cyclical rhythms of agrarian life were aggressively replaced by the straight, unforgiving line of industrial progress, marching forward second by identical second. When John Harrison was desperately trying to build his legendary marine chronometer in the 18th century, he was not just fighting the mathematics of longitude. He was fighting the fundamental laws of physics and the brutal, unforgiving reality of the open ocean. A clock at sea is subjected to conditions that would instantly destroy any normal timepiece. The massive wooden ships of the era rolled and pitched violently in the waves, completely rendering any gravity-based pendulum useless. The damp, salty ocean air aggressively rusted iron and brass. But the most insidious enemy of all was temperature. As a ship sailed from the freezing grey waters of the North Atlantic to the scorching, humid heat of the Caribbean, the metal components of the clock would physically expand and contract. Even a microscopic change in the size of a delicate balance spring would cause the clock to lose crucial seconds, which translated directly to miles of navigational error and potential death. Harrison's sheer, unparalleled genius lay in his invention of the bimetallic strip, a component made of two different metals fused together that reacted to temperature changes in exactly opposite ways, perfectly cancelling out the expansion and contraction. He eliminated friction by using exotic woods that naturally secreted their own lubricating oils, building a clock that was virtually a living, breathing mechanical organism. His obsession with perfection consumed his entire life, but it ultimately tamed the terrifying uncertainty of the global oceans. And as we look forward to the unimaginably distant future, the very physical relationship between the Earth and the Moon that gave us our first primitive calendars is slowly, inexorably changing. The ancient Babylonian astronomers, carving their cuneiform records into clay, could not have known that the Moon is very slowly stealing the Earth's rotational energy. Due to the massive, grinding friction of the ocean tides constantly pulling against the sea floor, the Earth's rotation is slowing down, and the Moon is physically drifting away from us at a rate of approximately 4 centimeters every single year. Hundreds of millions of years ago, during the vibrant age of the dinosaurs, a single day on Earth was only about 22 hours long, and a year contained roughly 400 days. If humanity, or whatever we might eventually become, survives for another billion years into the future, the Earth's rotation will have slowed so dramatically that a single day will last for hundreds of hours. The very concept of a month will fundamentally change as the Moon's orbit widens and slows. Our current calendars, perfectly calibrated to the present moment, are merely a temporary snapshot of a constantly evolving, shifting solar system. Time is not just passing. The very physical mechanisms that we use to measure it are slowly winding down, part of a grand cosmic clockwork that is destined to change beyond all recognition. Consider for a moment the strange and arbitrary nature of the 7-day week, a concept so deeply embedded in our global consciousness that we rarely question its origin. Unlike the solar year, which is dictated by the Earth's orbit, or the month, which is loosely tied to the phases of the Moon, the week has absolutely no basis in physical astronomy. It is an entirely human invention, a completely artificial rhythm imposed upon the calendar. The ancient Babylonians, observing the 7 moving celestial bodies visible to the naked eye, the Sun, the Moon, Mars, Mercury, Jupiter, Venus, and Saturn, associated each with a specific, powerful deity, and devoted a day to their worship. This astrological concept was eventually adopted by the Romans, who spread it across their vast, interconnected empire. Meanwhile, the ancient Hebrews established a highly influential 7-day cycle based entirely on the theological narrative of creation, culminating in a strict, unchanging day of rest. Over centuries of trade, conquest, and religious expansion, these two independent 7-day traditions merged and solidified, creating an unbroken, continuous cycle of days that has completely ignored every calendar reform, every leap year, and every single dropped day in human history. Whether a calendar was Julian, Gregorian, Islamic, or Hebrew, the 7-day week marched steadily onward, a deeply strange, deeply human pulse underneath the complex mathematics of the months and years, binding the modern global economy to a rhythm invented by ancient astrologers staring at the wandering planets in the deep desert night. It is a fascinating reminder that while we have successfully tethered our seconds to the absolute, flawless perfection of quantum mechanics and atomic resonance, the broader architecture of our daily lives remains deeply anchored in the ancient, mystical traditions of our distant ancestors. We are modern people living in a highly synchronized digital age, yet we still organize our grueling labor and our precious rest around the slow, wandering paths of the visible planets, as seen from Mesopotamia thousands of years ago. From the quiet, peaceful observation of the moon slipping behind the dark clouds to the brilliant sun casting a long shadow across an Egyptian temple. From the heavy, echoing iron ticking of a cathedral clock to the silent, invisible vibration of a trapped, frozen atom. The story of the calendar and the clock is the ultimate story of our desire to understand our tiny place in the cosmos. We have forcefully sliced the infinite continuum into years, months, hours, and nanoseconds, building a massive scaffolding of numbers to hold back the chaotic, terrifying flow of existence. But no matter how perfectly we define the second, no matter how precisely we calculate the long drift of the equinox, the true nature of time remains deeply, wonderfully mysterious. It is the invisible force that slowly shapes mountains, burns out ancient stars, and guides the quiet, steady rhythm of your own breathing right now. As you lie there in the quiet, let the arbitrary, rigid divisions of hours and minutes fall away completely. The loud clock on your wall and the tight calendar on your desk are just tools, beautiful, complex, and deeply human inventions. But they are not time itself. Time is simply the open space in which things happen, the gentle, constant unfolding of the universe, moment by peaceful moment. You do not need to measure it perfectly to experience it fully. You do not need to catch it or save it or track it perfectly. You only need to exist within it. Let the tight grid of the day loosen its heavy grip. Let the measured, ticking seconds dissolve back into the slow, quiet, deep river of the night. The stars are still slowly turning above, exactly as they did for the ancient wanderers, keeping a slow, majestic, silent time that requires no numbers at all. Rest now, deeply unbothered by the ticking of the clock, drifting peacefully in the endless, quiet expanse of the present moment. Sleep well, knowing that time, in all its infinite vastness, is gently holding you.